Okay, so let's look at this example of a typical rate law type question where you're asked to find the rate law, and in this case, to find the rate constant. So the question here says determine the rate law and the rate constant for the following reaction. So it gives you the equation and it gives you the data where at different concentrations of both reactants, you find, or what was found was the initial rate, all right? So let's proceed on this problem. So you'll notice that when you compare experiments 1 and 2, you'll notice that the concentration of the persulfate, that's the name of this ion, the concentration of the persulfate ion remains constant, while the concentration of the iodide is halved from 0.034 to 0.017. So this is what I'm going to do. I'm going to write down, let me go here and choose my ink. Okay, so what I'm going to do is write down, in fact, let me see if I can squeeze it up here since I think I'll need more space down below. I'm going to write down the hypothetical, or I should say, well, the general equation for the rate law for this reaction. So rate in this case is going to be equal to the rate constant times the concentration of the persulfate, S2O8 2 minus, raised to the x times the concentration of the I minus raised to the y, all right? So obviously x and y are the orders of the reactions with respect to the persulfate and the iodide. And our task is to find x and find y, all right? So as I said before, when we compare these two experiments, the concentrations of persulfate remains the same, but the concentration of the iodide is halved. And you'll see that it has an effect on the concentration, or I should say the rate of the reaction. So what I'm going to do is plug in the numbers here for experiment 1 into this equation. And what I'm going to end up with is a rate which is 2.2 times 10 to the minus 4 m over s is equal to k times 0.08 raised to the x times 0.034 raised to the y. And strictly speaking, I should include the units here, but they will cancel out anyway, as you're going to see shortly. But you need to include the units. Okay, so that's what I did when I plug in the numbers from experiment 1 into the hypothetical rate law. And then I'm going to do the same thing for experiment number 2. So in case of experiment number 2, I'm going to have 1.1 times 10 to the minus 4 m over s equals to k times the concentration of the persulfate, which is 0.08 m raised to the x, times the concentration of iodide, which is 0.017 m raised to the y. And I divide the top by the bottom, and some things will cancel out. The units will cancel out for sure. The m's and the m over s, all right? Now the 0.08 here and here will cancel out. The k's will cancel out. So the only thing that will, well, in fact, one more thing will cancel out, 10 to the minus 4 here and here. Okay, so what we'll be left with is 2.2 times, well, not times, divided by 1.1 equals to 0.034 over 0.017, all raised to the power of y, right? So basically, when you simplify this further, this becomes 2 is equal to 2 to the y, which means that y is equal to 1. So the order of the reaction with respect to the iodide is 1. So I'm just going to put y equal 1 here because that's what we determined. And I'm going to do some erasure here because I'm going to need the space below to do the calculation for the x. So let me go here, use my eraser, and take out all these. things. All right. Okay, so basically what I'm going to do now is determine the um, the order of the reaction with respect to the persulfate. So in order for me to do that, let me go back to my pen function here. In order for me to do that, what I'll do now is compare what happens in experiment 2 and experiment 3, because you'll notice between those two, the concentration of the iodide remains constant, but the concentration of the persulfate doubles, all right? So what I'm going to do is plug in the values for experiment 2 and 3 into the original rate equation here. So for experiment 2, it is 1.1 times 10 to the minus 4 m over s is equal to k times 0.08 m raised to the x times 0.017 raised to the y. So that's the equation for experiment 2. And then for experiment 3, you're going to have 2.2 times 10 to the minus 4 m over s is equal to k times 0.016 raised to the x times 0.017 m raised to the y. And I keep forgetting the units. M goes here, M goes here. All right. So again, like we did before, we're going to do some cancellations. This goes with that. That goes with that. The m's will cancel out here, 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 and here. And the 10 to the minus 4, just to make things simpler. Okay, what's going on with this? Okay, something is wrong with my connection here. Okay, I got it back. All right, so the 10 to the minus 4 will cancel out here and here. So what I'm going to end up with, I'm going to end up with 1.1 over 2.2 equals to 0.08 over 0.016 all raised to the x. And this will simplify to get 1 over 2 is equal to 1 over 2 raised to the x, which implies that x would be equal to 1. So basically, the order of the reaction with respect to each reactant would be 1. All right, so I'm going to put that there. Again, I'm going to do some erasure here because I'm going to need space now to calculate the value of k. And that's actually a very simple exercise. Let me just get rid of this first. Get rid of all of this. Come on, come on, come on, come on, come on, come on. Okay, so in this case, for the determination of the rate constant, it's very simple. All you have to do is rearrange this rate law that I have here, which I'm going to write down here. So K, oh, first, before I even do that, let me write down the rate law based on the order. So the rate law, which is what the question is asking for to begin with, is equal to K times concentration of S2O8 2 minus raised to the power 1 times the concentration of iodide raised to the power 1, right? So that's a rate law. That's what the question was asking for initially. Now the question is asking for the rate constant. So as I was saying earlier, what we have to do is rearrange the rate law to get K is equal to rate. So this is just simple algebra right here, divided by the concentration of S2O8 2 minus times the concentration of I minus, right? And all we have to do is choose any one of these experimental data and plug it into this equation. It doesn't really matter which one, right? So I'm just going to choose the first one, 2.2 times 10 to the minus 4 m over s. That's the rate for the first experiment, divided by the concentration of the persulfate, which of course is right here. So I'm going to put 0.08 m here multiplied by the concentration of the iodide, which is 0.034 m. And all I have to do is the arithmetic on my calculator. So 2.2 times 10 to the minus 4 divided by 0.08 divided by 0.034. And the answer I got when I round off to 1 sig fig is equal to 8 times 10 to the minus 2. But that's not the end of it, because we need to figure out what the units are. This m will cancel out this m. So in this particular case, the units would be m to the minus 1, second to the minus 1. And that's basically how that's done. All right. So this is a typical rate law type problem, right? I can guarantee that in a future assignment, or I should say quiz, or future test, you're going to encounter at least one of these problems. And this is basically how you'll deal with it. All right. Okay, so I'm going to stop here and move on to the next topic in the next video.